Today is September 29th, 2021. This is an interview with Professor John Speer, who is Director of the Advanced Steel Processing and Products Research Center and American Bureau of Shipping Endowed Chair for Metallurgical and Materials Engineering at the Colorado School of Mines. This interview is being conducted as part of the American Institute of Mining, Metallurgy, and Petroleum Engineers Oral History Project. My name is Kip Finley, and I am sitting with Professor Speer at the Colorado School of Mines in Golden. Today we'll discuss his experience working in industry and academia, his education, as well as his contributions to the ferrous metallurgy field. So John, you grew up in Bethlehem, Pennsylvania. Your father worked for Bethlehem Steel. How did that and the importance of steel industry in the community affect your decision to pursue metallurgical engineering?
Well, I don't know if I could put anything specific to that, although, it must have had an influence, right? Because Bethlehem is a town that had a lot of people working for Bethlehem Steel. So my father and grandfather worked for the steel company. My grandfather actually in Lackawanna, New York, and my father initially there. But my friends' parents, worked for Bethlehem Steel, and so there was a very steel-centric culture to the community. Bethlehem Steel affected a lot of things in town. At school. Students would bring projects that were, steel science focused and things like that. So you had that exposure as a child. I think we all did.
Did you know you wanted to be a metallurgical engineer when you entered Lehigh University?
I didn't. I went through different phases. I think when I was in, elementary school, I wanted to be a meteorologist. I don't remember why. I think I went a phase during junior high school or high school where I wanted to be a lawyer. I think I knew coming out of high school, though, that engineering was a good area for me to be studying. I kind of made that decision early at Lehigh, though, that metallurgy was a good field for me.
And you went to Lehigh not only for metallurgy, but you also went for tennis. Can you talk a little bit about how your involvement in sports complemented what you were doing with your education at the time?
Yeah, I guess I got recruited by the tennis coach at Lehigh, who I'd known for a long time, and I really liked it. Sort of a mentor of mine. It's not like I was a world-class athlete, but tennis had always been important, and I was pretty competitive. So that's always been part of my life. Lehigh was in my hometown. So I think, even in graduate school, I played varsity tennis. So I actually played 7 years of college tennis because I went to graduate school overseas and they didn't have any eligibility restrictions for graduate school. So it's been part of my life. My friends, were often people that I, played on the tennis team with, and we traveled together. And so, I have some close relationships that, I maintain to this day from tennis teams that I played on, both as an undergraduate and a graduate student. You have to manage your time well, but it's a good outlet, I think, and, I enjoyed it a lot.
Yeah, it's useful to have those outlets.
And I think, we have students here at Mines, graduate students who have been competitive athletes. Mark Taylor actually was one of the better tennis players in Colorado. He came here from Texas as a graduate student. Michelle Kent is kind of a really high-end runner in the program now. So I think I understand, and I encourage students to still pursue those things because, they can still be successful as graduate students.
Yeah.
Our administrator in the center, Karen Apt, is a professional soccer referee. On the weekends, I think that makes her life busy, but she organizes things and gets things done. And so, I encourage people to kind of pursue those other avenues.
Yeah, they're important. I guess it's worth noting too that Michelle's also alumni of Lehigh University.
That's right.
Alumnus.
I didn't think about that.
So how did you ultimately choose to do metallurgical engineering then?
Um, I guess I fell into it. I don't know if I could put my finger on that. When I was at Lehigh as a freshman, all of the freshmen took a class that exposed them every week to a tour and laboratory facilities, discussion about what the field meant, and the metallurgy department did a really nice job with that. And it was one of the earlier ones that I went to, I think, and so it just sort of felt right, and I made a decision without putting a lot of thought into it, and I didn't actually ever really second guess that. Um, you know, as I tell students here, I probably could have been happy doing any number of things, but I was happy doing that, and it's worked out well.
I guess following that, you must have really liked it because you chose to pursue a PhD at Oxford, which is a pretty unique pathway for an undergraduate student to pursue graduate school. Can you tell us a little bit about what led you to make that decision, how that experience came about?
Um, when I was at Lehigh, I had the opportunity to support some research programs as an undergraduate. So working with Professor Goldstein, who was an expert in iron meteorites. So I worked on polishing meteorites and assisting graduate students who were doing um, more in-depth analyses. One of whom was Al Romick, in fact, and who I still interact with occasionally, and Dave Williams, um, who was recently dean at Ohio State of Engineering. He and Professor Goldstein worked together in the transformations and microscopy areas, so I was exposed to that as an undergrad, and it seemed interesting. And so the people I was working with were graduate students, and I was doing well in school, and they were encouraging me to think about graduate school, and so I applied to Lehigh, and I also got into the sort of Rhodes Scholar applicant pool, and that's how my interactions with Oxford started. And so I was going to do one of those two things, and ultimately I decided, to go to Oxford because um, I guess a lot of reasons. I mean, it was an interesting university to think about. I hadn't traveled much outside of the region of the country that I was brought up in. So it was kind of interesting to think about that. I lived at home as an undergraduate student, and so that was a big change, going overseas, in fact. But um, and Oxford obviously has a good reputation, so that was part of this decision as well.
Sure, I appreciate the response. I guess I had a similar experience in determining to go to graduate school for me, but for me it was because I did undergraduate research with you in the Steel Center at the time, and I had the same kind of rationale for making a decision for attending graduate school. So I appreciate that response. Um, you went to Oxford. You worked for Professor David Edmonds, and you've since maintained a pretty close relationship and some close collaboration with him. Also, can you tell us a little bit about that?
So the educational system is a little bit different there, and so very research focused for graduate school, as are we, although our students also take a lot of classes. And I think the Oxford undergraduates spend more time doing metallurgy and materials as undergraduates before they go into graduate school, and so probably have a little bit more of an advanced background than I did, or the U.S. students do. And so doing a research-focused degree there was probably a little bit different. I don't have all the coursework that our students, I would say, benefit from a lot, really learning important information from people that really know it well. So when I needed to learn something that I didn't know as a graduate student, kind of had to figure it out and learn it myself. And so I didn't have as good a teacher in that respect. But you do learn the maybe skill of trying to teach yourself, and so you're sort of not afraid of learning either. And so I think I was really well prepared for research, having the undergraduate background and then a very research focused graduate program. And then working with David Edmonds, the advising relationship is maybe a little bit different in the UK, because the student has a lot of independence. And again, I think that gives you that sense of independence, the ability to take on problems that you don't feel too comfortable with. And I think that's a good skill to have in research, because we're never quite sure where we're going or how we're going to get there, right? You're always kind of walking into the fog as a researcher. And so I was comfortable with that, that sort of feeling, pretty early on in my career. We got into, so David had been working with the Ministry of Defense for a long time in the UK on steels, and then he got a grant to work on uranium alloys for kinetic energy penetrators, with some interactions in the U.S. with the Picatinny folks, and so I was the first student to work in that area in his program, and but still working on phase transformations. And with his background in steels, we were, he talked about uranium steels, if you will, right? So the Ferrous phase transformations area was very relevant to what we were doing in uranium alloys. And then later on, we started to work together, because some of the projects that we were doing here sort of evolved into areas that I knew David had worked on, bainite and silicon effects in steels with retained austenite, and we developed some collaborations later on that way.
It's fun. Did you have the opportunity to collaborate with other students there?
So I had friends who were other students. We probably didn't have the kind of student collaboration that we do within the research center, the Advanced Steel Processing and Products Research Center at Mines. But yeah, students helped one another learn. One of my office mates, John Postul, who was also in David Edmonds' group, he had been there a little longer than me, so showed me how to do different things, and I stay in touch with John today a little bit. But each student was kind of independently responsible for their project. And I guess I would say the projects were not necessarily closely aligned in the case where, what one student was doing was highly relevant to the work that another student was doing.
When you completed your PhD, you came back to the United States. What opportunities did you have coming back to the United States?
Well, that's a good question. Being outside of the country, it wasn't like I was sort of being actively recruited by all sorts of people in the U.S. I had some university people ask me if I was interested in academic positions. I came to a conference in Philadelphia. I think it was 1983. I met some people there. I did have a couple of job interviews. I did an internship at Bethlehem Steel between my senior year graduating and when I started graduate school. So I was familiar with the research program and was pretty comfortable there. And so that was something that I was, always had a strong affinity for. And I ended up doing that. They were pretty enthusiastic about hiring me, and so going back home was a good thing for me. And so that's sort of a natural step, I think. The lab in Bethlehem, Homer Research Labs, was pretty well regarded, and um, you know, and I think our students working in the U.S. with an industry-university collaboration have a lot sort of different experience than many graduate students do, where I was just working on my project trying to get my degree, not really working extensively with people that might someday want to hire me.
Right. What position were you hired into at Bethlehem Steel?
I think I was called a research engineer,
Okay.
and there were multiple levels of those in the company.
Right. And so working in Homer Research Labs, what was the research and development environment like at that time?
It was good. Well, everything was new for me, so I wouldn't have had anything to compare it with. But they had just gone through a corporate downsizing, and so I think for the folks who were there, that probably affected morale a little bit. But I thought morale was pretty good. There were really a lot of very good people at Homer Labs, and we were working on interesting things. Everything I was learning about steel, and working for Steve Hansen, um, and who was a very energetic, knowledgeable person. I learned a lot about steel in that group. Other good people who were doing a lot of good things today. We were working closely together. So I think it was a pretty good environment. Um, the company had been struggling for a few years. It was sort of early on in the transition where the steel industry was struggling in North America. So I think projects were getting a little bit more short term, a little bit more oriented to solving problems in the manufacturing locations. But as a new PhD graduate, I was working on some things that were important but fairly fundamental. So it was a little while before I started, doing things that were more directly relevant to day-to-day plant operations or day-to-day customer needs.
What sorts of applications were the projects you had?
So at first I was working on plate steel. So we worked on some fundamental microalloying effects. Then we applied those in the area of plate steels for towers and poles, actually. And we weren't necessarily developing new property combinations because um, the properties were specified by ASTM, but we were essentially trying to increase the mill productivity by doing thermomechanical processing at higher temperature. So if you could finish the rolling process at higher temperature, it would take less time to roll the plates, and the mill productivity for those products would be increased. So that's the first area that I sort of got involved working on some more direct product development for customer activities with a more senior engineer, Hallie Abrams. So if you know the Abrams three-circle method metallurgy, that was Hallie, and he was a character. Then the next thing I worked on was Navy shipbuilding grades. So we developed HSLA 65, HSLA 80, and that was a new generation of shipbuilding materials. I took part of that over from John Pauls, who had really done the early HSLA 80 development. And then I handed it off to Keith Taylor, who you also know, who I think developed some higher strength grades after I moved into sheet steel product development.
Interesting. How much interaction did you have directly with customers during that time?
So I didn't have as much interaction directly with customers in my first few years. I mean, there were people, with more experience and who were sort of better at doing that probably than me. But then when I moved into the sheet steel area, part of our responsibility was also customer technical support. And so, I ended up doing more and more of that. While I was in the plate product area, I was involved on some industry teams that we had to support either the shipbuilding industry or the machinery industry. And so I was exposed to some more, um, cross-functional activities in the company. So getting to know people who did, different things in manufacturing or marketing or selling or R&D. And so it's sort of a process of learning. And then in the sheet steel area, we were doing direct customer support of problem solving, direct operations support of problem solving, and then longer term customer support, which would be really trying to find out what their future needs were and how we could, develop research programs that would have products in place to meet those future needs.
Interesting. And you evolved into some leadership positions within the company. Can you tell us about those positions?
Yeah, I was a research supervisor for maybe my last 8 years at Bethlehem. And so I had a group of researchers and technicians that I was responsible for. And I had some training, I thought, that was very good. Bethlehem had, some pretty good training programs, and so I found some of the management training was very insightful, right? Some things that were counterintuitive to me about, leading people and leading people differently depending on, you know, where they were in their career with their experience um, and skills, right? Some people are better off, um, being closely managed, like a new employee, and other people are better off, being sort of encouraged and left to, you know, accomplish things. And I had both um, kinds of people in my group, and so that was really helpful to me as we, you know, tried to accomplish what we were trying to do in the group.
I guess there's some utility in understanding what your own personality is relative to the personality of the people that you're managing.
Yes, and I think, that, so I haven't really had a lot of direct supervisory responsibility since then. Um, I haven't been a department head, for example. Um, but I think, you know, in our center, the things that we do together, working with students, mean you're effectively leading and managing them. And so I think that experience was really helpful to me in that regard. And then one of the other things that, I had some specific leadership training because we had some opportunity for that as well. And I found that also very insightful. So leadership not being the same as management. And, one of the ways to think about it too is that we're all leading um, or following, I guess, all the time. And so it's not, leadership isn't just about being in a position of authority and making decisions for a group, but you know, it's speaking up and providing input, to someone else in authority when they really need that, that information, and it's risky. That's leadership too. So all of us are responsible for being leaders at the right time, at different times.
Yeah, that's an interesting perspective. And I guess another facet of leadership that's interesting is the ability to listen at the right time as well.
Yes. Not knowing when to lead and when to
Yeah,
follow
right,
sometimes. Not
right.
that I have always made the correct judgment on that, but
Were there critical skills that you had to learn as you transitioned from the academic graduate school environment to the industry environment?
From an academic to industry, well, so as a student, I was researching uranium alloys. So one of the things I had to learn was ferrous metallurgy. But I did a lot of reading of, sort of classic ferrous metallurgy papers because, that's where a lot of the phase transformations, background comes from. So I was pretty well prepared to do that, and I had really good colleagues who were very good and very knowledgeable, and so I learned a lot from them. Obviously, anything in supervision, management, leadership was all new, and you had to learn that, but you didn't have to learn it overnight. I think students are expected to hit the ground running, maybe to a much greater degree than I was, right? So there was an expectation that your professional development would take some time, and you'd be exposed to a little bit more, and then a little bit more, and a little bit more. So my style is to try to pick up as much as I can and watch other people and learn from them. And so I don't know if I could put my fingers on what I needed to learn, but I feel like I was given, a good opportunity to learn those things through my experiences.
I guess I'll follow up on that. If students today are expected to hit the ground running at a quicker pace, does that mean that our educational model has changed or needs to change to accommodate more professional development early on to help them transition to the workplace?
That's a good question. I think the educational model has changed a little bit. I mean, students are doing at Mines the EPICS program. They're working in teams. They're doing senior design. Um, they're doing meaningful internships where they're expected to be part of the team and accomplish things for the host company during their internship. So I think the students seem to be pretty well prepared in that sense. Um, our graduate students, I think, are very well prepared in that sense. So as working together, the graduate students that we're working with are making presentations to industry twice a year, to fairly big groups that, I would have been nervous as a student probably, and I'm sure they are as well. But they have that experience. They're writing professional quality reports. So we demand a lot of them, and I think they probably are a little bit better prepared a little bit earlier.
Yep. So we've referred to the Steel Center in Mines, including just now several times in conversation. So you moved to Mines in 1997. I think I met you in 1998 as an undergraduate student here. Um, what motivated your decision to pursue an academic career after several years in industry?
Yeah, I just sort of fell into that too. It was something I hadn't really ever been planning or preparing for. I didn't even have a resume prepared when I had a kind of an informal conversation with David Matlock at SAE one year. They were searching for a replacement for George Krause, and that might have been in March. I knew about that search in August or September prior, um, and we just had a conversation, and um, they had already been interviewing, I think, multiple people, and I didn't really have a great understanding of the university environment even. Right, I did my graduate studies overseas, so I hadn't been embedded in a U.S. graduate program, and so, but I put a resume together one weekend and submitted it and interviewed soon after that, and I ended up here in Golden. It was a unique position for me. I mean, they were really looking for somebody that I felt like the job description was a pretty good fit with who I was. Um, I like to work with I hadn't really worked with students other than, my summer jobs were giving tennis lessons, and I worked with, church youth group. But, that there's some parallelism between that and working with students, supervising, early career researchers, people that I hired out of school was a little bit like I'm teaching, or I convinced myself of that, I guess. But it was really the one academic position in the country that's maybe would have fit what I was doing. So it was kind of interesting to think about. Big change, but it wasn't something I was really seeking. It just felt like it was the right thing to do at the time.
So the aspects that attracted you were working with students, the particular research direction, anything else?
Um, yeah, I mean, coming to Colorado was kind of interesting. I think, we benefit in our student and faculty recruiting from Colorado, but I don't know if I knew enough about what I was getting into even to, to, to know to know how to answer that.
Right.
It's just like it felt like it was the right thing to do, and if I was ever going to do something like that, that was the time to do it. And I didn't have a great understanding of the academic environment. I did talk to some people that I knew in academia about it, before I interviewed or decided to take the position.
So one of your primary roles was a faculty member in the Advanced Steel Processing and Products Research Center at Mines. And I guess you have a unique perspective because you were both a sponsor of the center at Bethlehem Steel and a faculty member of the center since that time. Can you tell us about your perspectives in both roles, or were the perspectives different in both roles?
Well, I'm sure the perspectives are a little bit different, but I sort of understood the center, partially at least, from an outsider's perspective. They were, I had been hiring some students from the center, so had high regard for the center. David and George, who were leading the center, are highly regarded, and people I looked up to, and so the center had a good reputation, and it felt pretty good. I'm not too sure if I remember all of the perspectives, what it felt like to be on the other side. I know some of the sponsors were enthusiastic about the fact that there was somebody that had a direct industry background, because our sponsors are very sort of strongly interested that the center projects and the students maintain an understanding of the relevance of the programs. And so I had a background probably that, maybe it doesn't completely fit industry, and maybe it doesn't completely fit academia, and sort of a background that's sort of a cross between the two that was an interesting fit with the position. And I sort of joked to the faculty and administration here at Colorado School of Mines. I wonder, I wonder if they would hire me today, under the same circumstances, because there's so many well-qualified candidates for faculty positions. The funding environment, is probably better in the federal areas that are, a little bit more fundamentally focused, with a little bit maybe not less relevant, but let's say longer term relevance. Big problems that people try to work on, and you may or may not be able to individually impact the solutions, I guess. I feel like many of the things we work on, we are able to have an impact in a, let's say, intermediate time frame.
I guess along those lines, did your experience working with the center as an industrial representative impact how you thought about designing and implementing projects as a Steel Center faculty member?
Maybe not actually. I think that when I came here, um, I kind of had to change my thinking and kind of starting over and trying to learn about what it was like to be a faculty member, what it was like to do university research. So I think I was probably trying to you know kind of figure out what would work rather than saying, oh, okay, well, I saw this from the outside, I know what to do here. But I think you bring whatever you have to the table in everything that you do. And so there probably was some of that, but I don't think it was conscious.
Were there any things that surprised you or you felt like you had to learn about in terms of things like technology transfer from the industry side and the academic side?
Um, so technology transfer, um, we had a very strong patent group at Bethlehem Steel that I worked closely with on some things, and they did a really good job. And uh, Mines has a strong patent program now, but when I came in and for a while I was here, it wasn't something that we had really a strong capability in. There's some things that we probably would have had a better chance of patenting actually if we were a little bit better at Mines, but um, technology transfer is a little bit different too, because in the consortium, all of our member companies own all of our work. And so part of our job is to communicate what we're doing to them. When you're working at a company, um, one company wants to, keep proprietary most of the work. So it's a very different environment. In some ways, at the university, you have a lot more exposure, to people broadly around the world. You can talk about what you're doing. You can collaborate with anyone that you choose, and um, that's an exciting opportunity, actually.
Yeah, certainly. As you said, the Steel Research Center is a unique environment in terms of industry collaboration. It's been going for several years, which I guess could be one metric of success. What do you think other metrics of success should be for a center like this one?
For a center like ours, so obviously, at a university, probably student success should be an important metric of everything that we do. And I think we're all proud of our students, and they're doing really well. I think if we can impact the companies with the work that we're doing, or impact their thinking about things that they might do later. We're doing pre-competitive work, so we might be able to think about projects without some of the shorter term pressures that the corporate researchers are doing. And so um, if we can do things that the companies appreciate, um, it's hard to measure that, but I think that's an important metric. I think maybe one of the main ways to measure that is whether our sponsors remain engaged with the program, and I think largely they are engaged, and that engagement is, part of why we succeed. But that's an important metric. And then there are other metrics that are important from the university standpoint, as far as viewing the department or the faculty or the students as being productive. And so we're trying to do those things too.
I guess in terms of innovation, you've been a part of a lot of innovative technologies. One of the primary ones is quenching and partitioning technology, which you developed, I guess, in 2003 as a start. Broadly, as you've been a part of these innovations, do you have insight about how you identify a problem and come up with an impactful solution to some of these types of really interesting research projects?
I think everyone does it probably differently. And, what ideas you have that you decide to work on is important. And who knows if we've had really good ideas that would have been, you know, turned out great if we worked on them, but we decided they weren't, great ideas. I guess the way I view things, though, I try to, um, if I see something in quenching and partitioning, for example, there were fundamental pieces that, there were mechanisms operating, that we hadn't thought about before. And um, so if we could understand those mechanisms and employ them, then we might be able to do something with it. And so, that particular development started in that way, as did some of the earlier microalloying pieces in my career, right? So I try to start off by understanding the fundamentals as well as you can, and then trying to understand how those fundamentals fit with possible applications, and then where are the fits the best. And then, are there any ideas coming out of that? And of those ideas, which ones are good and which ones aren't so good? So I feel as a researcher, knowing what you know and what you don't know is important. And I don't know if that's a skill or it's just a sort of intuitive thing, but I feel like, I have some strength there, and I feel like I've been fortunate in making some decisions sometimes about what ideas are good and what ideas aren't good. And because often, the ideas that aren't good are not necessarily being enthusiastically supported by other people. Um, and you have to develop them. You have to make a decision that you're going to take time, outside of your other things that people want you to do to try to develop those ideas. And those things, a few of those things have kind of worked out. Um,
So there's a filtering process to decide what's a good idea and a bad idea, but there's also a process by which you have to develop enough information to communicate whether the idea is a good one or not.
yes, well, actually, it takes time before you have something that you can communicate in a way that people perceive it as a good idea as well, right?
Mm-hmm.
So you have to, sort of develop that, and you might have to show people, and even then, you know, it's not like people will necessarily be wildly enthusiastic about the idea, but some people might be. In the quenching and partitioning development, we were very fortunate that, one of the companies that became a sponsor company, um, Steel, they heard about some of the early work we were doing when Amy Clark gave a presentation at a conference that we organized, and they were in the process of designing a processing facility, and it was easy for them to, well, easy, relatively easy. Nothing is easy, but they were able to design some capability into that processing facility that allowed them to be an early adopter of the technology, and the ideas went from there.
In your time as a faculty member in the Steel Center, the center has evolved from being an entirely North American sponsored steel research center to a global research center. Can you talk a little bit about that?
Yes, that was really an interesting evolution. I think when the center began in 1984, and that was about the time I was beginning my career at Bethlehem Steel. I remember Professor Krauss actually coming to Bethlehem to talk about their efforts in starting the center. But it was a North American only membership. The Industrial Advisory Board wanted the center to be focused on North American companies. There was a little there was globalization was starting to happen. It was very competitive. They wanted to keep the intellectual property within North America, but the industry evolved a lot over the next 15 years or so, where the companies themselves were tying up globally, we're buying overseas companies, we're merging, and shortly after I came to Colorado School of Mines, we had a strategic planning discussion that sponsor representatives participated in. They they encouraged us to go ahead and try some participation of overseas companies, and POSCO was our first member company from overseas, and now we've had involvement from Korea, Japan, China, Brazil, Netherlands, Sweden, Germany, France, Austria, Brazil, Argentina, Mexico, Canada. And so the center has this, what to me has been really exciting opportunity to bring all these people together from across the world to sort of work on common problems, to understand what's going on in ferrous metallurgy in different parts of the world, to have steel users working with steel producers globally, with our students. And so that's been a hugely rewarding and enjoyable part of my job. It's a little bit stressful sometimes. We've traveled a lot, except during COVID, in order to try to maintain face-to-face contact with the ASPPRC sponsors. But it's been I think a unique opportunity for all of us who have been able to be part of ASPPRC that way.
As you've kind of described the steel industry and the research and development environment today, there's clearly a lot of exciting opportunities in steel, though it's not always perceived that way by the general community. Um, what would you tell someone that they might not recognize about steel research and development, about opportunities that they might not be recognizing if they weren't aware of the field?
That's a hard question. So, people are looking for the newest thing sometimes, right? Well, what's new? What's completely new to the world, and how can I make an impact on that? Whereas, steel's been around, or iron and steel, for as long as you can think of, and has been an important part of the economy for 150 years. If you think about where different steel products have impacted different kinds of infrastructure, and so steel is used in huge quantities around the world in all sorts of applications, and we take it for granted. And the new things that are happening in steel at any given time are a little bit opaque to the general public, right? If the steel on your car is much stronger than a car that looks just like it that you used to own, you might even not know it, right? So it's so the technology that's embedded there isn't necessarily transparent to the public. Although if you think back over time, your parents probably remember well the car rusting through after a few years, or the muffler and tailpipe being replaced every 12 to 24 months, right? And so there are technology enhancements that have come along, and those are no longer, my children wouldn't even be, familiar with having to change the muffler or something like that, right? So, but I think that's a lot of a lot of the reason that, maybe the public perception isn't the same as the reality. And then there were difficult times for manufacturing industries in general, not just the steel industry, as the economy was becoming more globalized, and exchange rates and trade issues and all that were coming into play. So, but it's a complicated question.
Yeah, it is. And I guess along those lines, steel probably is going to play a major role in future sustainability efforts. And I was wondering if you might want to comment on that role of steel going forward.
Um, yeah, and sustainability efforts are going to play an important role in activities around steel processing and steel production. It's an area that hasn't really been a central expertise of mine, right? As a microstructure developer, if you want to, sort of take my expertise to the, kind of to the most specific area. But it's clear that sustainability is growing in importance, and growing really quickly right now. The decarbonization of global industry is getting a lot of attention, and the steel industry, to the extent that it uses coal in the blast furnace, or that uses coal-based electricity, generates a lot of carbon dioxide. And so there are technologies being developed with hydrogen, particularly in Europe. But there are other technology opportunities that the next generation is going to have, a great time researching and developing, to transform steel production. And then on the product end, there are going to be continued pressures for, higher strength, lightweighting of vehicles, for example, using different, recycling of scrap is going to take a different role, perhaps. And so there's a lot of technology development that's going to be a great opportunity for the students going forward.
What courses have you enjoyed teaching at Mines?
So I've enjoyed teaching all of the classes. I've taught undergraduate, graduate, from, I guess, freshman to graduate students, freshman success seminar, introductory materials, phase equilibria and phase diagrams, which is a core class that I teach, and a Ferrous physical metallurgy graduate course called Current Developments in Ferrous Alloys. So the latter two are the ones that I teach most of the time. It's great being in the classroom with the students, so I enjoy teaching all of the classes. The FaceTime with the students is great. Preparing for class and grading students' assignments, that's not the fun part, but being in class is great. And I think probably my phase equilibria class is a little bit unique. We don't use a textbook, but I think it's really good information that the students get. And my current developments class is a little bit the same. I kind of constructed it around my background. Professor Krauss taught it before he retired, and I replaced him, but we probably have a little bit different content. And but I think that class is really good for our students in not just in the Steel Center, but doing physical metallurgy in general.
Has the way that students have approached learning changed over your time at Mines? And I guess there's a pretty abrupt change that we all had to deal with last year with COVID-19. But in general, has the way students approach learning changed?
Yeah, that's, it happens so slowly that I'm not sure if I notice it, but clearly digitalization has is growing in importance. And I wouldn't say that I'm necessarily an early adopter of classroom technology, right? I mean, the more junior faculty who are exposed to newer technologies earlier and have less invested in existing technologies probably are adopting things earlier. Obviously, COVID was a big shock. We went not just from digitalization, but to actual remote learning. But software systems that support the educational process are, there are much more of those than there used to be. When I started teaching, if we wanted to show a microstructure on the screen, we were using transparencies for that, right? So even the idea of bringing a PowerPoint file into class is something that's changed over my teaching career.
I guess the inverse of that, has your approach evolved over time in terms of how you mentor students in the research process or teach students in the classroom?
I'm sure it has. I'm not sure I could exactly put my finger on the changes, but you change as a person as you have more experiences. I'm probably more willing to delegate different things to my graduate students than I would have been early on and let them struggle with them without helping, to give them that experience of struggling. Not that I don't want to, kind of throw a life preserver if they're struggling with something, but I want to let them, swim around a little bit until they really need it. And then when they don't need it anymore, sort of take it away and let them, develop a little bit more independently. So I think I allow the graduate students to be a little bit more independent. With the undergraduate students, I'm not sure how much my style has changed, although the technologies in the classroom have changed. I've probably gotten a little bit easier grading as I've gone over time.
You have two daughters. Has seeing how they learn and are educated affected your perspectives on the educational environment at universities at all?
Probably, that I don't know if I've ever thought about anything around that question, but being a parent, I think affects just everything, the way you look on life and understand people and interact with people. So it probably does have important impacts, but I might have to think a little bit more before I could give you a sort of coherent answer on that one.
So you've had another interesting position at Mines, and a unique position as the associate vice president of research for the university. You probably had some opportunity to do some impactful things. I know you had some opportunity to do some impactful things. Can you describe what the appeal was for that position and what you enjoyed about that position?
Well, the position gave me some exposure to the university and university leadership and what was happening from that standpoint, and then we interfaced with a lot of different visiting national labs and companies. The role is to help develop research programs, research funding for the university, as well as in some cases administer policy kinds of things. So it was a fun experience. And, as I mentioned before, one of the ways that I learn is by kind of watching people do things. And so, I had the opportunity to, watch the academic leadership and, learn how different things work at the university and, see people use their gifts in particular ways. And, so you learn from all those kinds of experiences. It was very different, and it's fun to do different things from time to time as well. So
Yeah.
I thought it was a good experience. From more specifically, I think, as far as what programs did we actually have particular impacts on, We were deeply involved early on developing the Critical Materials Institute that's still going strong. It's a Department of Energy large program related to rare earth minerals. Remersek was, was early on, and we helped a lot to, help Remersek thrive.
And Remersek is renewable energy.
Renewable energy materials, science and engineering research center or something like that. Sorry about that. Remersek has been replaced by some other activities, but they made some great faculty hires at the time, and those faculty are thriving. It's an important area for Colorado School of Mines, and so that was a fairly big impact as well. We worked really hard on a mixed construction grant program that I think we got very close to, but weren't successful. And then the other thing that was fun about it is really working with faculty across campus and getting to know the other faculty on campus, because we don't have as many opportunities to get to know each other across the university outside of serving on different committees together. But that particular role, I got to work with all the researchers on campus, which was kind of fun.
The other role that faculty members have is service, including external service to the community that they're involved in, and that includes professional societies. Though you've been involved in professional societies for a long time, including AIME member societies, AIST. You've also been involved in SAE, ASM International. How did you first become involved in professional activities like these?
My first involvement was ASM, and I received a student scholarship and attended a Lehigh Valley chapter meeting as a student, so that was my first exposure. I had a little bit of student exposure when I was in the UK, and then when I came back, some more involvement in ASM and TMS, although at the time TMS was I'm not sure the right word. They wanted maybe steel to be a little bit less important component of TMS, and so the ferrous part of TMS kind of migrated to ISS. Now TMS more recently has emphasized and brought back pretty strongly some ferrous component. I got involved in SAE. Really, I was doing that in part to help the company when I was at Bethlehem Steel on the Ferrous Metals Committee, and we were doing a lot of organizing for SAE. I was developing automotive products at the time and applications technology. I continued doing that for quite a while I was at Mines, and then more AIST started in the early 2000s. Although I had some involvement with ISS before that, which was part of what came together as AIST. But I also had, just before the merger, had some involvement with AISE on the training side. So I got more involved with AIST. We were organizing some conferences in the steel product development area, and I think those have, that's been a series of conferences that were fairly important. And then I got involved. I was nominated to serve as a trustee of AIME after that, and then eventually became an officer of AIME.
So in today's societies, what role should they play in the development of young engineers? And I guess what kinds of roles should young engineers pursue in these societies today?
Well, I think it depends on the person, but I think the professional societies are valuable for people to interact, to get a broader view to participate in conferences and see what other people are doing, to have a sense of community, that, they belong to, to this broader community of professionals that work in their fields. And then, if people want to get involved in leadership, that provides them, other opportunities to interact, although, it also gives them more responsibilities. And so people, I think, at different times in their life might have, more time or less time to do that. But I think that people who are involved in professional societies sort of value that involvement. If they're involved in leadership, I think they value that involvement as well. So I think, it's beneficial to the community and beneficial to, to the people who are participating and leading. For young professionals, if they're involved in leadership, it gives them experiences and, background in leadership as well.
Can you talk about your time and accomplishments in serving as president of AIME?
So that was enjoyable. We got to interact with all of the other engineering societies. So to see different perspectives and just, engage with that community was kind of fun. We also distributed funds to our member societies. And AIME has a foundation, and so the trustees are responsible for growing the principal and distributing funds and doing other programs. So there were some nice things around that. I think one of the challenges that the board struggled with while I was a board member of AIME, AIME has a long history. We're having the 150th annual meeting this coming weekend, in fact. And so, AIME has a long, proud tradition, and has, AIME was the sort of origin of what are now 4 independent professional societies: AIST, TMS, SME, and SPE. And these are 4 very large, very successful, very important professional societies that were all once part of AIME, and now are sort of independent, but under the AIME umbrella. AIME itself now is somewhat small, so we always struggled with what the identity of AIME should be relative to these, incredibly successful member societies. And so, my feeling about that is to really, the legacy of AIME is the success of those member societies, and so trying to direct my efforts into supporting the success of the member society. So we had some governance changes while I was president of AIME. And I wouldn't say that I really drove those governance changes, but I guess I'd say I facilitated them. So some changes in the board structure, closer alignment with the needs of the member societies. And I guess we'll find out how that all works out at the 200th anniversary of AIME. But I hope that that challenge to the identity was sort of stressful at times, and my hope is that people that are really serving AIME now have lower stresses and are really able to accomplish the things that AIME can do to support the member societies.
Yeah, great. Along those lines, but also under the category of some of your accolades, you've also recently become a member of the National Academy of Engineering. And I was wondering if you might want to comment on, that's a major accomplishment, what that accomplishment means to you and your role in the National Academy of Engineering.
I think that, I guess I'd say I've been fortunate to be blessed with some of the accolades. I hope I deserve some of them, but the National Academy, and while in academia, I think we view it as an award or an accolade. I think the Academy views it as an opportunity to serve the country. And so I want to be a little bit careful about characterizing the Academy membership as an award. I think most of the Academy members are involved trying to support on a volunteer basis some technical needs of the country. And so I'm involved in a global industrial sustainability program on behalf of the academies. Right now, I know our colleague David Matlock was involved in a program related to hydrogen-related failures. So doing things that are important to the country. But by the same token, being an Academy member is also a great honor. It was great to go to Washington. I took my family for the induction, and so it means a lot to be an Academy member, to be viewed as somebody that's done something that's worthy of that kind of election to Academy membership.
Yeah, absolutely. Going back to professional societies and your role in education, what role do you think societies, universities, faculty members should play in recruiting students to engineering and specifically to material engineering professions?
Mm-hmm. I was brought up in a steel producing town, so I knew that metallurgy was a field that existed. My father was had a metallurgy degree. A lot of our students that go into engineering don't know that metallurgy or materials engineering or material science exist. In fact, I've researched that a little bit, and I talked to the students about it. Looking at what students sign up for as possible university programs when they're taking the PSAT exam. There are very few of them that identify materials as something they're thinking about studying, whereas there are massive numbers of students who identify other things, and so as a discipline, as a profession, we need to inform students often after they arrive at the university that we exist, what we are, why we're valuable, and sort of recruit students into the discipline. Because there are more students that graduate from college than think they were interested in that discipline. But it's still a strong discipline. But I think we have a good message because our students are in demand in every kind of industry. And so at least at Colorado School of Mines, our student numbers have been growing through the time that I've been here. That makes some things difficult. Teaching is a little bit more difficult. We don't have the ability to have the same kind of personal relationships with the undergraduates that we did when the class sizes were half what they are now. But the students are getting hired even at bigger numbers. So I think we're doing some things right.
And it's been a little bit of evolution in universities where materials people are present as faculty members in multiple departments, which also impacts the educational programs. How does that affect the recruitment and education and evolution of materials engineers going out into the field?
That's interesting. So the materials field, I guess, has become much more broad. The kinds of backgrounds that people have, who consider themselves to be materials people, is broader. And so there's a more interdisciplinary characteristic to us. In the cases where we have, broad materials backgrounds across campus within the actual undergraduate materials program, there's probably a more closely contained curriculum that, that provides students, with the specific kinds of backgrounds that employers expect from metallurgy and materials graduates. But in the graduate programs, people are doing all sorts of things, and it's probably both healthy and complicated.
Absolutely. I just have one final question to wrap up, and it ties into a theme that we've been talking about throughout this conversation about leadership. What advice do you have for young leaders in the materials profession in general?
Young leaders, engage whatever you're doing. Don't take yourself too seriously sometimes. Try hard, be prepared, be thoughtful. Life has ups and downs, so everything comes with challenges, and be prepared to deal with the challenges. The world is always changing, so the challenges are changing. Most people are not spared difficult times in their life, so be prepared to deal with those in some sort of resilient way as well. Try to serve whoever is is your client, if you will. What are the needs that you're trying to fulfill through your efforts in your career?
Well, thanks, John. That's a really insightful answer, and I've enjoyed this conversation. I've learned a lot from you as always. So thanks for the discussion.
Well, thank you, Kip. I hope some of it is valuable.